Hello and welcome to another math video. Today we're going to be taking a look at solving square root and other radical equations. So just a little background there. So a radical equation, it's an equation that has a variable in a radicand or a variable with a rational exponent. If it has an index of 2, then it's a square root equation. We are going to assume that all radicals and expressions with rational exponents represent real numbers for this. They do mention here, solving a square root equation may require that you square each side of the equation. That can introduce extraneous solutions. That is true, and I'll be talking about for each one why or why not the can turned into it did introduce extraneous solutions, or it couldn't have introduced extraneous solutions. So I'll talk about that for each one. Basic strategy for these, to solve a radical equation: isolate the radical on one side, raise each side to the power suggested by the index. So we'll get started with problem number 1 here. First thing we need to do is isolate that radical. So we've got the 3 on the same side as the radical. I'm just going to kind of sneak it in down here. So we subtract 3 from both sides. That isolates the radical for us. We've got 2x minus 3 equals 5. Really, the square root of 2x minus 3 equals 5. So from here, then we have that square root isolated, so we can go ahead and square both sides of the equation. And actually, before I go ahead and do that, I just want to mention, notice how it's a square root equals a positive number. So when we square both sides, we know that, of course, the square root of 2x minus 3 can't be negative, and 5 is positive. So we're squaring two positive things. So in this case, we can't be introducing extraneous solutions by doing this, because we're squaring two positive things. And over here it mentions, do you need the plus and minus sign? The answer, no. When we take the square root of each side of an equation, you do. But here we're squaring both sides. So if we had the 2x minus 3 were getting squared, and we had to square root both sides, then yes, we would need a plus minus. But in this case, it's the square root of 2x minus 3, so we don't need the plus minus. In this case, we do end up, again, the reason we square is because that will get rid of the square root. So we get just a plain 2x minus 3 there, and we get 25 here. From here, it's just like solving any equation. We're going to add 3 to both sides of that equation because we're trying to isolate that 2x. We move this up a little bit here. And then we get 2x equals 28. And so we'll just divide by 2. And so we turn out to figure out here that x is equal to 14. One of the great things about solving equations, you can always go back and check to make sure that works. In this case, we'd plug the 14 in here. 2 times 14 is 28. 28 minus 3 is 25. The square root of 25 is 5. 3 plus 5 is 8. So it doesn't take a whole lot of time to check that. Here are a couple of equations for you to try solving. So if you want to go ahead and pause the video at this point, you can try these on your own, and when you resume, I'll go ahead and work through these. Okay, so for this first one, we need to isolate that square root, so we will add the 5 to both sides. So I'll just, that's probably a bad color. Let me switch colors there. So we'll add 5 to both sides. That's really a 5, I swear. Okay, and so we get square root of 4x plus 1 equals 5. Yeah, just get rid of a little bit of that there. Don't need that all the way over. Okay, now we're ready to square both sides. And again, notice when we're squaring both sides, the 5 is positive. I'm just going to kind of sneak the squaring in over here. And the squaring and the square root, they just undo each other. So the left side is just 4x plus 1. We get 25 again. So we'll subtract the 1. 4x equals 24. Divide by 4. X equals 6. And I mentioned before again how you can check that pretty easily just by plugging the 6 in and make sure that it works. Certainly worth your time, especially on a quiz or test. to double check, make sure that that works. But again, we cannot have introduced extraneous solutions because we squared both sides, but both sides could not have been negative. That's the key, and we'll kind of explain that more when we get to ones where there can be extraneous solutions. This next one is practically the same thing. We'll take and subtract 6 from both sides. In this case, that gives us 1. So square root of x plus 4. I draw those kind of long, don't I? That will equal 1. So squaring both sides, difficulties with my writing today, so hopefully you can read it. Again, the squaring just undoes the square root. You square 1, you just get 1. It's kind of boring. Alright, and then in this case there's really not much to do. We just subtract the 4. And this time we get x equals negative 3. I think that's our first negative answer we've come up with so far. And again, I've mentioned before, squaring both sides. The key to extraneous solutions is that when we're squaring both sides here, both 1 and the square root of x plus 4 can't be negative. Okay, 1 is positive. It's not, you know, it just can't be anything else. It's positive 1. Square root of x plus 4 can't be negative. So we're fine squaring both sides where we do not create extraneous solutions. It is certainly okay, though, to get a negative for our answer. That doesn't mean anything, you know, doesn't have anything to do with extraneous solutions. Our answer can be positive, negative, whatever. And again, you can plug the negative 3 back in, make sure that it works. Pretty simple to check that one. So again, I highly recommend continuing to check your answers, even if extraneous solutions aren't possible, like in this case here. All right, next we're going to take a look at some questions where we have a rational exponent, and we're not going to quite do this the same way that they recommend. We're going to handle this a little bit differently. So if we have an x to the m over n equals k, we're not actually going to raise each side of the equation to the n over m power. We're going to show you a little bit different way to do that. We're still going to isolate, in this case, the power first. So for this particular question here, we'll divide by 3. I swore I wrote a 3, it just didn't look like a 3 when it came out. Alright, so dividing by 3, let's see, and the risk of doing too much at once, I'm going to go ahead and switch from rational exponent form to radical form. So this would be a cube root of x plus 1 squared. And that's going to equal 12 divided by 3. I mentioned divided by 3, I think. I must have undone that a little too much. So that's going to equal 4. Now, it doesn't make much difference which one you take care of first. But if you can manage the numbers, they're not too big, it's going to probably be a little bit easier to deal with the radical first. That will make the number bigger, because when I'm getting rid of that cube root, I actually take both sides to the third power. So calculators are going to be handy here. I'm going to come all the way over here. So I get an x plus 1 squared equals 4 to the third power, which is 64. Now, on the previous questions, they were really all square root questions, and so we talked a bit about the fact that extraneous solutions were not possible for those. In this case, dealing with cube root, when it's an odd root, you can't have an extraneous solution whatsoever. You don't have to worry about it at all. From here, we would square root both sides of the equation. Now, earlier we mentioned when you square root both sides, really any even root, whether it's square root, fourth root, whatever, that's when you need the plus and minus. So really get a plus minus here. And so we end up with x plus 1 equals positive and negative 8. So really that is two equations. That is x plus 1 equals negative 8, and that is x plus 1 equals positive 8. So we subtract 1 from both sides, we get x equals negative 9. And we subtract 1 from both sides, we get x equals 7. Again, extraneous solutions are not possible, but it doesn't hurt to double check by plugging those back in and making sure that they do work. All right, this next one is the same sort of deal. They did have it in radical form for us already. Again, we aren't going to bother writing it as a rational exponent. We're just going to deal with the radical as it is. But we first have to isolate that radical. The radical is being multiplied by 3, and then we're adding 1. So we're going to actually subtract 1 from both sides. So that will give us, I'm going to come all the way over here, 3 times the 5th root of that x plus 1 to the 3rd power, and that's going to be equal to 24. Now, I'm sure you guys probably already figured this out because they take a while to do things, but we're going to divide by 3, and then we get the 5th root of x plus 1 to the 3rd power, and that equals 8. All right, now, here is where taking the 8 to the 5th power is a bit of a pain. So what we can do instead is, remember with these parentheses, we can also think of this as the 5th root of x plus 1. That's all to the 3rd power. So I'm actually going to go ahead and cube root both sides here. So cube rooting both sides, and partly I'm okay with doing that because I know the cube root of 8 is 2, and so that gets rid of the 3rd power. So we end up with, if I come over here, the 5th root of x plus 1 equals 2. And I don't have to worry about pluses and minuses or anything like that because all of my exponent is odd, so no plus minus when I take the 3rd root of both sides like it would be if it were squared and I took the square root of both sides. From here now it's a little bit easier to take both sides to the 5th power because 2 to the 5th is a little bit easier. Granted, calculators can do a lot of that stuff for you, so if you'd rather take the 8 to the 5th power and then cube root that, it's still going to work out to be the same. We get that x plus 1 out of the radical, so we subtract 1 from both sides, and we find out that x is 31. And again, no chance of extraneous solutions on this one. Notice, again, we only ever dealt with odd powers and roots. And again, the key there really being it's an odd root, so no possible extraneous solutions. Here, I just realized I did all that work and I didn't remember to hit record, so I guess I'll just talk my way through it here. So with this one, first thing we need to do, isolate the power, so we divide by 2. That gives us 4. It's kind of a mess here, but we get switched from the 2/3 power to the cube root of x plus 3 squared. We can take care of the cube root first, so cube both sides. 4 cubed is 64. We then take care of the squaring by square rooting both sides. We have to add in the plus and minus, so we get positive and negative 8. We set up 2 equations, subtract 3 from both sides. In both of those, we get x is negative 11 and x is 5. All right. The next one. Again, we have to isolate that power, so we add 5 to both sides of the equation. We get a 3 over here. Switch from the 1/3 power to the cube root of 6x plus 9. In order to get rid of the cube root, we cube both sides. Now it is an odd root, so we don't have to worry about extraneous solutions at all. 3 cubed is 27, so from here it's just like solving a regular equation. We just subtract 9, that gives us 18. Divide by 6, we get 3. And again, even though extraneous solutions are not possible, it doesn't take too long and certainly doesn't hurt at all to plug that 3 in and make sure that that works. And even though we didn't talk much about actual extraneous solutions, just about the fact that there really couldn't be any in these particular situations, I promise you in the second part of this lesson we will get into some equations that actually introduce the possibility and even actual extraneous solutions. So, as always, hopefully you found this helpful, and thank you for watching.